Hey everyone! Today we are going to dig into a concept that's, believe it or not, over 2,000 years old, but it is quietly running the code of our future. It's a fantastic story about the hunt for perfect certainty, a huge intellectual crisis, and most importantly, how that whole journey gives us a powerful strategic framework for anyone building tech today.
So let me ask you this, because for every single person leading a tech team, this is the question, right? How do you build a system you can actually trust? Whether you're designing software, you're building an AI, or just managing incredibly complex data, you have to know that your system is reliable, that it's consistent, and that it's built on something solid. So how do you get there? Well, the answer starts way back in ancient Greece.
All right, let's get into it. To really understand the tools we're using right now, we have to go back to the original dream. I'm talking about the ancient Greek obsession with absolute, provable truth. They were desperate for a way to build knowledge that was completely unshakable.
Now, this quest wasn't just a one-off thing. You can think of it like a multi-century relay race of brilliant ideas. It all kicks off around 300 BC with Euclid. He gives us the blueprint for deductive reasoning in his famous book, Elements. And for centuries, that was the absolute gold standard. Now let's fast forward more than 2,000 years to 1899. A giant in mathematics, David Hilbert, takes Euclid's original ideas and just rebuilds them with modern rigorous logic, fixing all the little assumptions Euclid made. But he didn't stop there. By the 1920s, his ambition just exploded into what's known as Hilbert's program, a massive attempt to put all of mathematics on a single, provably perfect foundation. So what is this axiomatic method that they were all so passionate about? Well, at its core, it's actually beautiful in its simplicity. You start with just a handful of statements that you declare are self-evidently true. These are your axioms. And from that tiny set of truths, and only from them, you use super strict rules of logic to derive every other statement or theorem in your whole system. It's kind of like building an entire sprawling city starting with just a few types of bricks and a very clear set of construction rules. And this quote from Hilbert, wow, it just captures the incredible scale of what he was trying to do. This wasn't just about organizing geometry anymore, no way. This was about creating a perfect, self-contained universe of mathematics. A system so secure, you could prove it would never, ever produce a contradiction. Think of it as creating a bug-free operating system for all of math. Just incredible ambition. And for a little while, it really seemed like this grand vision of absolute certainty was maybe, just maybe, within reach. But just as the project was hitting its peak, this beautiful dream of a perfect foundation collided head-on with a reality that nobody, and I mean nobody, saw coming. So in the 1930s, this quiet logician, Kurt Gödel, comes along and publishes a paper that just changes everything. He didn't just find a tiny crack in the foundation. He proved that any foundation, if it's powerful enough to do basic math, will always have cracks built right into its structure. The whole dream was about to come apart at the seams. And this is exactly where it all came to a head. Hilbert's perfect system needed two things to work. First, completeness, which means any true statement could be proven. And second, consistency, the ability to prove the system itself had zero contradictions. What Gödel did was prove that for any system complex enough to be useful, you can't have both. He showed there will always be true statements that you simply cannot prove within the system, and even worse, a system can never prove its own consistency. I mean, this was a bombshell. It was a stunning, game-changing revelation. Now, this might sound like the end of the story, right? A total failure. But it really wasn't. This so-called crisis was actually a transformation. By showing the absolute limits of the method, Gödel forced it to evolve. It got humbled for sure, but it was also reborn, not as some philosophical symbol of absolute truth, but as an incredibly powerful and practical tool.
You can really see this journey in three big steps. First, the axiomatic method starts as this quest for absolute, perfect truth. That was the vision of Euclid and Hilbert. Then bam, it hits a wall. Gödel comes along and shows it has proven unavoidable limits. But it's that third step that matters for us. It emerges from that crisis, humbled, yes, but way more valuable, as a pragmatic, powerful tool for building and verifying the complex systems we all rely on today.
And that brings us right back to right now, and back to you. Because this reborn, pragmatic, axiomatic method is the intellectual bedrock for so much of the technology you build, you lead, and you rely on every single day. And this history connects directly to the engineering challenges we face right now. Think about software reliability.
Axiomatic approaches like Hoare logic give us the formal rules to prove that your code is correct before it ships, helping prevent those critical, show-stopping bugs. Or look at AI. Logics like first order and modal logic create the provable rule sets that allow a machine to reason consistently. And when you're dealing with messy, real-world data, frameworks like axiomatic rough set theory actually help you manage that uncertainty so you can pull out clear insights from an imprecise world. So, what's the big takeaway here? The really crucial point is that understanding this history isn't just some academic thing. It gives you a real strategic framework. Knowing that every system has limits helps you manage its complexity. Realizing that your system's core assumptions are basically its axioms, well, that forces you to see them as critical design choices that define its rules and its boundaries. And it reminds us that verification isn't magic. It's a rigorous engineering discipline with a deep and, honestly, fascinating history.
And that leaves us with one final question, something to take back to your teams. I want you to look at the systems you're building, the products you're shipping, the platforms you manage. What are the unspoken, self-evident truths you've built them on? What are the foundational axioms of your technology? Because understanding those is the very first step to building systems that you and your customers can truly trust.